What's going on, guys? John Alder here from Codemy.com, and in this video, we're going to finish our linear regression for Pandas, Scikit-Learn, and Python. Alright guys, like I said, in this video, we're going to finish our linear regression. But before we get started, if you like this video, want to see more like it, be sure to smash the like button below, subscribe to the channel, give me a thumbs up for the YouTube algorithm, and check out Codemy.com, where I have dozens of courses with thousands of videos that teach you to code. Use coupon code YouTube50 to get 50% off lifetime membership. It's all my courses, videos, and books for a one-time fee, which is insanely cheap. All right, like I said, in this video, we're going to finish up our linear regression model. So in the last video, we did our train test split. So we took some of the data and put it in the training set, some of the data in the test set, and get it all ready to do the next step, which is the linear regression. So we're still working on this file called linreg. As always, you can find a link to the code in the pinned comment section below, as well as a link to the playlist with all the other videos in this Pandas series. So check that out if you haven't so far. So like I said, in this video, we're going to continue on and create our linear regression. So we need to import some things. So let's go from sklearn.linear_model. We want to import our linear regression model. All right. So like I said, we're going to be creating a linear regression, and we do it by importing that from Scikit-Learn. Scikit-Learn does most of the heavy lifting, as you've probably noticed throughout the last few videos. So let's come down here and create a linear regression model. So to do this, super simple. We just create a variable. I'm going to call it LR, short for linear regression. And we set this equal to a linear regression instance. And boom, that's it. Now, if you want to look at this, there's nothing really to see. It just says, hey, it's a linear regression instance, right? So, all right, we've now created a linear regression model. Now we need to train that model. So remember up here, we have a training set and a testing set. So we need to take our training data and sort of dump it into the model and say, hey, start learning, right? So we do that fairly easily. Let's come down here and let's say train the model on the training set. This is how the model learns, right? So to do that, we call our linear regression and then the .fit function. And the fit tries to take the data and fit it to the line. I guess you could sort of think of it like that. Now we need to pass in our training data. So that's just x_train, remember capital X. And we also need the y_train. And remember, that's just the stuff from up here, right, from the last video, right? So we've got our x train stuff and our y train stuff. We've got our x test stuff and our y test stuff. So the x train and the y train go together into this fit function. So now we can run that and we get this little linear regression thing again. We can ignore that. It doesn't really tell us anything. Now we need to predict on the testing set. Remember, we have a training and a testing set. So we're going to create something called y_pred, or sometimes y_preds. We'll just say y_pred, and these are y predictions. And this is going to be an lr.predict. And we want to pass in our x_test. Right, we're doing the testing stuff now, so we're passing in our x test, which of course came from up here, right there. Right, so we've got x test and y test. We're passing in x test to get our predictions. Now, our y_preds are basically they're the predicted values of the target variable based on the features. Right, so remember our features are these things: age, sex, BMI, BP, all the blood serum levels, right? Those are the features. And our target is this target, this last column here, right? So we're trying to predict the target based on our model, right? And then once we have those preds, those predictions, we can compare them to the actual values. Because we have those, right? That's the actual values of the target variable. And we do that to evaluate the performance of the model. Right, so I know I'm kind of typing all this stuff in, but I think it's really good to have this on the screen that you could refer back to, because we throw out a bunch of things here and it's really easy to forget what they all do. So have these notes in here, I think it's probably going to be useful. So again, these are just the predicted values, the predictions, right, of the target variable based on the features. So, hey, given these features, what do we predict the target to be? Like, so as a person's age increases, what do we predict their likelihood of getting diabetes to be? Is it going to go up? Is it going to go down? Well, that's what we're doing here. So if we want to look at this and see what this is, we can go y_pred. Oops, probably want to spell it right. There we go. And it's just going to be a bunch of numbers. Well, how many numbers? Well, we can call a shape thing, and it's going to be 89. Well, that makes sense. This is test data, right? And remember up here, when we did the testing shape, that was 89 rows. So of course, down here, we're going to get 89 rows, 89 outputs, 89 predictions, right? So, okay, that makes sense. So, all right, we've got our linear regression. We've trained it here. Now we're making predictions. So we pretty much have everything now. We just need some sort of output to tell us, hey, did this thing work? Is it good? Did it predict something correctly? Is it not predicting something correctly? What do we do? Well, there's a couple of sort of ways to get conclusion type data out of here. And we're going to look at several different statistical things and then we'll actually graph this a couple of different ways to see how well this model did. So we need some metrics, right? We need some numbers. Was it a success or not? So let's go from SciKit-Learn dot metrics. We want to import several things. We want the R2 score, and I'll tell you what all these are in just a second. We want the mean underscore squared underscore error. And we also want the mean underscore absolute underscore error. And like I said, I'll tell you what all these are in just a second. So, all right, let's do some evaluation. Let's evaluate the performance of the model. So we're going to get the R2, and I'll tell you what that is in a second. We're going to get the MSE, the mean squared error. I'll tell you what that is in a second. We're also going to get the mean absolute error. And again, I'll explain all these. And we also probably want the intercept, and we'll talk about that too. So first, let me just give you the equations for these, and then we'll talk about what they are and what they mean. So for R2, we want the R2, oops, you know what? I misspelled R2 up here. R2 score. There we go. We want the R2 score, and that's going to be based on the Y underscore test and the Y underscore pred, right? For the mean squared error, we want the mean underscore squared underscore error, and I'm getting this and this from up here. That's what we just imported, right? If that wasn't obvious. And to get this again is just the Y underscore test and the Y underscore pred. For the MAE, we want the, you guessed it, mean underscore absolute underscore error. And again, we want the Y underscore test and the Y underscore pred. So finally, the intercept is the LR, our linear regression dot intercept. And we put this little underscore at the end of it, right? So let's print out all of these things real quick, just so we can see what they are. And then we'll talk about what they are and what they mean and why they're important. So the R2 score, that's just going to be our R2. So let's also print our mean squared error. And that's just going to be our MSE. Let's also print our mean absolute error. And you guessed it, MAE. And finally, let's print out our intercept. And that's just going to be our intercept. So if we shift run and get these, we get an R2 score of 0.45. We get a mean squared error of 2,900 and change. We get a mean absolute error of 42 and change, and an intercept of 151. So what are all these numbers? What do they mean? Was this good? Was it bad? What is all this? So let's start with the R2. So the R2, and let me just comment on here. This is the variance of the dependent variable, which is our target, right? Explained by the independent variables, variables, and that's of course our features, right? So what does this mean? Well, let's sort of bring this over. So basically, in layman's terms, this is how well the model fits the data. So higher is better, right? So this is going to be generally from 0 to 1, right? So this is right around the halfway mark, right? So the MSE, and maybe let's copy these and instead put it like this. And let's say R2. I'm all over the place here. So MSE. So the MSE is basically the average squared, mean squared error, average squared distance between the predicted and actual values. So here, lower is better, right? Because remember when we had that scatter plot with a line through it, we're trying to find the distance between the little dots and the line. So the the closer it is to the line, the better. That means there's less of an error. That means it's done a better prediction, basically, right? So that's that. Finally, we can do MAE. This is the average absolute distance. So this is the squared distance. This is the absolute distance. And sometimes they're negative, so we need an absolute value. So it's absolute distance between, same thing, the predicted and actual values. And also here, lower is better as well. Finally, we have the intercept. That's just the starting point of the regression line on the y-axis. And these things will make sense the more you play around with this and sort of understand what these are. We're going to look at the charts and graphs in a minute. Maybe that'll help you understand them. But I know I'm throwing a bunch of weird terms out, but believe me, they'll start to make sense after a while. So that's just the value of, let's put this on another line. Value of the dependent variable, which is the target, when the independent variables, which are the features are 0. So if this is a positive, then the target increases as features increase. If it's negative, it's the opposite, right? So if as age goes up, the chance of diabetes goes up if this is a positive number. If this was a negative number, if age went up, then the chance of diabetes would go down, which probably wouldn't make sense. We wouldn't think that would be the case. So we see here that the intercept is 151. That's positive. That's good. So, all right, we've got a bunch of metrics here. So at a glance, we can look at these and say, the R2 score is pretty good. It's, about halfway. Got the mean squared 2,900, mean absolute 42, and an intercept is positive, which is good. So, okay, this is great, right? But it's also fun to just see these things. So let's import matplotlib.pyplot as PLT, and let's make a little chart real quick here. So we want to plot the predicted versus the actual values. So here, the predicted values of the target variable are plotted on the x-axis, and the actual values of the target variable are plotted on the y-axis. And what this will tell us is, hey, if the model's a good fit, the points should be pretty close to the diagonal line, indicating a strong linear relationship between the actual and predicted values, right? So that'll make sense in just a second when we look at this thing. So let's create this guy. Let's go plt.scatter. We want a scatter plot. And this is just going to be our y_test and our y_preds. And let's give this an alpha of like 0.5 to make these dots a little transparent, because there's going to be a lot of them. And if they're solid, it's going to be kind of hard to see what's what. But we can make them a little bit transparent. We know how to do that from earlier videos in this series just by giving it an alpha. So that'll create the scatter plot. And then let's also plt.plot. Let's put that red line right through the middle of it. And we get that with, create a Python list here. And we want y.min, the min value of our y's. We want our y.max. And these are both functions. And then we also want, again, our y.min and our y.max again. And then let's give this a color of like red to make it a nice red line. And we're good to go. So that'll work. Let's give this some labels though while we're at it, because why not? So let's go plt.xlabel. And this is going to say actual values. And let's give it a plt.ylabel. And these are going to be our predicted values. And then let's give this chart a title, plt.title. And this is going to say predicted versus actual values in our linear regression. Okay, so let's plt.show this guy and take a look. Shift enter to run this, and boom, we get our scatter plot, our line going through it. And this looks pretty good. You can see they're all kind of grouped around this line nicely, which is what you want to see in a linear regression model. If they're just scattered all over the place, that means there's not a really good correlation between this line and the data. So very cool. So we can look at these metrics, right? And we could say, okay, this is probably predicting pretty well because our R2 score is pretty good, 45, and the intercept is positive. We can see it's definitely positive. The dots are all sort of grouped around the line pretty good, and yeah, looks pretty good. Misspelled values. There we go. One last thing we want to do is probably plot the residuals. So what are residuals? Well, the residuals, and again, I'm just going to type all this out so you have it in your notes because this is all overwhelming the first time you look at it. The residuals are plotted against the predicted values of the target variable. So if the linear regression model is a good fit, or we can say a good fit for the data, then the residual plot should show a random scatter of the points around 0 with no, say, discernible trend, right? They're just going to be scattered everywhere. So let's create this guy. Let's go plt.scatter again. And here we just want our y_pred and our y_test minus y_pred. And let's give this an alpha of, again, let's go 0.5. Because you can see like up here, some of these overlap. And so it's nice to have a slight transparency. So, all right, that looks good. Now we can make this look nice. Let's go plt.xlabel. And this is going to be our predicted values. And then let's plt.ylabel. And these are going to be our residuals. And let's plt.title this guy. Let's say residual plot for our linear regression. Something like that. And let's plt.show. Oops. Oh. equal y test minus y pred. There we go. All right. So here we see this kind of loosely scattered plot here. And here's 0, right? Right around here. And you can see they're not all grouped right around 0. So if we had imagine a line that went straight through at 0, you don't want to see them bunched right up around that line. And you can see they're scattered up here, down here, all around. It's nice and loose. And that's a pretty good residual plot. So what we want to see is a random scatter around 0. And to my eye, it looks fairly random. And we're good to go. So that's all for this video. If you liked, be sure to smash the like button below, subscribe to the channel, give me a thumbs up for the YouTube algorithm, and check out Codemy.com where you can use coupon code YouTube50 to get 50% off lifetime membership. So that's access to all my courses, over 50 courses, thousands of videos, and the PDFs of all my best-selling coding books. Join over 160,000 students that earn a code just like you. My name is John Elder from Codemy.com, and I'll see you in the next video.